Ever wonder what powers your phone, laptop, or electric car? It's not magic, it's the lithium-ion battery. These batteries have revolutionized our lives, making devices smaller, lighter, and more powerful. Before lithium-ion, portable electronics were bulky and short-lived. Think brick phones and battery-hungry music players. The invention of rechargeable lithium-ion batteries unlocked a new era of mobility and connectivity. Every text, photo, or map check relies on lithium ions shuttling between the battery's anode and cathode, creating the current that powers your device. Charging just resets those ions for another cycle, an elegant process refined over decades. Lithium-ion batteries have powered revolutions in communication, transportation, and entertainment. But as our energy needs grow, we have to ask, can this one hero keep up? Or do we need a whole team of battery superheroes? The science suggests it's time to expand our lineup. Lithium-ion batteries are amazing, but they're not a one-size-fits-all solution. They've revolutionized how we power our lives, from smartphones to electric vehicles, but their strengths come with important limitations. Imagine trying to use a hammer for every job. Sometimes you need a screwdriver or a saw. The same goes for batteries. Different tasks require different tools, each with their own strengths and weaknesses. Lithium-ion is perfect for powering our phones and laptops, but it's not ideal for storing energy for entire cities or running heavy industry. These larger-scale applications demand different performance characteristics. Lithium is also a limited resource, concentrated in just a handful of regions around the world. This makes global supply chains vulnerable to disruptions and causes prices to swing unpredictably. Different applications have different needs. Electric cars require batteries that deliver high energy, fast charging, and robust safety, while the power grid needs storage that's cheap, long-lasting, and ultra-safe, even over decades. Standard lithium-ion can be too expensive or risky for massive deployments, especially when safety and cost are critical factors. Plus, the flammable liquid inside poses real safety concerns, especially for sensitive uses like medical implants or an aircraft, where failure isn't an option. That's why scientists and engineers are searching for new battery chemistries and technologies, hoping to meet our diverse and growing energy demands with safer, more sustainable solutions. The future of energy storage will be about finding the right tool for each job, matching the battery to the task for maximum efficiency and safety. One battery can't do it all, and that's actually a good thing, because it drives innovation and helps us build a smarter, more resilient energy future. If lithium isn't the only answer, what about sodium? The same element in table salt. Sodium-ion batteries are emerging as a promising, affordable alternative. Sodium is abundant and cheap, making it ideal for large-scale energy storage. Imagine grid-sized battery farms storing solar and wind power at a fraction of the cost. Lower costs mean more storage, more renewables, and a cleaner grid. Sodium-ion batteries are heavier and less energy-dense than lithium-ion, so they're not for slim phones or sports cars. But for stationary storage, weight doesn't matter. Cost and abundance do. Sodium-ion batteries could become the backbone of our electrical grid, easing pressure on lithium supplies. They're not replacing lithium-ion everywhere, but carving out their own crucial niche. The right battery for the right job makes the whole system stronger. That's a win-win for our energy future. Imagine if our batteries could hold even more energy without getting any bigger. That's the dream driving scientists and engineers today. Enter silicon, a material that could change everything. Silicon, best known as the backbone of computer chips, has a remarkable property. It can store up to 10 times more lithium ions than graphite, which is the standard anode material in most batteries today. This breakthrough could mean smartphones that last for days on a single charge, or electric cars that travel hundreds of extra miles before needing to plug in. Alternatively, batteries could become much smaller and lighter, paving the way for ultra-thin devices, lightweight wearables, and even electric airplanes that were once thought impossible. But there's a catch. Silicon expands and contracts dramatically as it charges and discharges, causing it to crack, break apart, and degrade much faster than traditional materials. To solve this, scientists are experimenting with nano-sized silicon particles and flexible composite materials that can better withstand the stress of charging cycles. If these efforts succeed, silicon anodes could unlock a new era of innovation, transforming everything from portable electronics to electric vehicles and even future modes of transportation. Packing more energy into the same space doesn't just mean longer battery life. It opens up possibilities for entirely new technologies and applications. The challenge is tough, and the road ahead is full of obstacles, but the potential rewards are enormous. Silicon could represent the next giant leap forward in battery performance, efficiency, and design. Around the world, researchers and startups are racing to make this vision a reality, pushing the boundaries of what batteries can do. Who knows? In the near future, the power for our devices and vehicles could come from something as simple and abundant as sand. What if we could make batteries dramatically safer by removing the flammable liquid inside them? For decades, lithium-ion batteries have powered our devices, but their liquid electrolytes can be volatile and dangerous, especially under stress or damage. That's the promise of solid-state batteries, which replace the liquid with a solid electrolyte. This breakthrough could transform how we think about battery safety and reliability. Solid-state batteries are far less likely to overheat or catch fire, making them ideal for electric vehicles, medical implants, and even aircraft, where safety is absolutely critical. The solid electrolyte also unlocks the use of high-performance materials, like pure lithium metal anodes, which can significantly boost both energy density and battery lifespan, allowing devices to run longer and charge faster, but making a solid that conducts ions as efficiently as a liquid and remains stable as the battery expands and contracts during use is a huge scientific and engineering challenge. Manufacturing these advanced batteries at scale is tough and expensive, requiring new techniques and equipment, but the safety and performance benefits could be game-changing for countless industries. Scientists are experimenting with ceramics, polymers, and even hybrid materials to find the perfect formula that balances conductivity, flexibility, and durability. If they succeed, solid-state batteries could redefine what's possible in energy storage, powering everything from smartphones to electric grids with greater safety and efficiency. The journey is slow, filled with setbacks and breakthroughs, but the potential rewards are enormous for our electrified future. Safety and performance, together at last, something the world has been waiting for. The next battery revolution could be solid, ushering in a new era of safer, more powerful energy storage for everyone. Batteries are now a cornerstone of global strategy, not just gadgets. The ability to store energy shapes economies, security, and climate goals. Countries leading in battery tech will have a major edge, just like oil shaped the last century. For industries, better batteries mean winning the race to electrification and renewable energy. Large-scale batteries are the missing link for a reliable, clean power grid. Batteries store excess solar and wind power, making renewables practical and resilient. Governments are investing billions in battery research, manufacturing, and raw materials. This isn't just about better phones, it's about energy independence and a sustainable future. The global battery race is on, and the stakes are higher than ever. Inventing a new battery in the lab is just the beginning. The real challenge is mass production. Scaling up from a prototype to millions of reliable batteries is called crossing the valley of death. Manufacturing requires extreme precision. Even tiny defects can ruin performance or safety. New chemistries like solid-state or silicon anodes need entirely new factories and processes. Building these factories costs billions and takes years, so companies move cautiously. The journey from lab to market is slow, expensive, and full of surprises. Success depends on mastering both science and large-scale engineering. The winners will be those who can build the best batteries at massive scale. Innovation isn't just about discovery, it's about making it real for everyone. The battery revolution happens in factories as much as in labs. The future of batteries isn't about one winner. It's about teamwork. Each battery chemistry has strengths: lithium-ion for high performance, sodium-ion for cost and scale, solid-state for safety. Think of it like a sports team. You need different players for different roles. Lithium-ion with silicon anodes is your star quarterback, great for cars and laptops. Sodium-ion is the reliable lineman, perfect for grid storage. Solid state is your safety specialist, ideal for critical applications. By combining their strengths, we build a more resilient and versatile energy system. The best future is a team effort. The battery-powered future is a diverse ecosystem, not a one-size-fits-all world. Your next electric car might use a high-tech lithium-ion battery, while the grid relies on sodium-ion farms. This mix-and-match approach makes our energy system stronger and more resilient. Diversity protects us from supply shocks and price swings, and lets us optimize for every need. Scientists and engineers are pushing boundaries, and governments are investing in this quiet revolution. The next decade will define our energy landscape for generations. Better batteries mean more than better gadgets. They mean a cleaner, more sustainable world. Batteries are key to fighting climate change and expanding access to reliable power. The next generation of batteries will power our progress as a civilization. That's a future worth building together.